to 1.4. The next thing I want to talk about is an equation you'll need to memorize, and this is actually something you will use in science too. If you haven't yet already, you will in the future. I'm not sure if you've learned this. There's two different, well, there's probably more, but there's two different main ways that temperature is measured. There's Fahrenheit and Celsius. We use Fahrenheit. I know Israel uses Celsius. And so if someone gives you a temperature in Fahrenheit and you want to convert it, you can use this equation. If someone gives you something in Celsius and you want to convert it, you can use this equation. So the equation is in the middle here. So it is Celsius on the left equals 5/9 times Fahrenheit minus 32. Okay? So if you know the Fahrenheit, you pop that number in there and you solve for Celsius, right? If you know Celsius, you pop that number in there and you solve for Fahrenheit. Okay, so definitely have that in your notes and you'll need to memorize that. Not too bad. I mean, there's really only 5/9 to 32 in there. It's not bad. Make sure you have that. Let's look at an example with it. Example 3 says solve the temperature formula for F. So that means take the formula that you just wrote down and then get F by itself. Okay, so you'll notice there's parentheses there. In this case, what we actually need to do is get rid of the stuff outside the parentheses first. Okay? I'm going to go ahead and flip this so that it's a little easier to do. So I have 5/9 times F minus 32 equals C. So if I want to get F by itself, like I said, I first need to get rid of the stuff outside the parentheses. You'll notice that outside the parentheses is being multiplied by 5/9. Okay? And what that means is we need to divide by 5/9. Or another way of thinking of this, because it's going to get messy on the right if we do that way, is to multiply by the reciprocal, which means to multiply by the flip. If there were a number on the right, it wouldn't matter. Okay, dividing by 5/9, your calculator can help you. But since there's not a number, it's actually going to be way easier to rewrite it like this. So I'm going to divide the left side, multiply the left side by 9/5. Okay, that's the same thing as dividing by 5/9. It's just going to be easier this time. So if I do that to the left, I have to do that to the right. All right? And then what happens is, here's why it works. Look at the left-hand side. 9 times 5 is 45. 5 times 9 is 45. 45 over 45, well, that's just 1. Okay, and that's why this whole thing cancels out. All right? And so on the left side, I'm left with F minus 32 equals C times 9/5. Think about it. If that were C times 2, what would be a better way to write that? It would be 2C, right? So if it's C times 9/5, it's 9/5 C. Okay? Well, now that the stuff is gone on the left side, outside the parentheses, I don't actually need the parentheses anymore. Okay? There's nothing separating this here. There's nothing to separate it from. So I'm just going to rewrite this without the parentheses. And now you can see if I want to get F by itself, right, that's my goal this whole time, getting F by itself, I just have to get rid of the 32. So in order to get rid of the 32, it's being subtracted, so I'm going to go ahead and add it. That gives me F on the left. On the right side, notice once again, okay, this has a C, this does not. So I cannot put those together, and that's fine. So my answer is just F equals 9/5 C plus 32. Okay? So that's how I get F all by itself for that equation. All right, let's take a look at one more example. Example 4 says, which has the greater temperature? So we have the sun, which is 11,000 degrees Fahrenheit. We have lightning, which is 30,000 degrees Celsius. So that's like comparing apples and oranges, right? I can't definitely say lightning is more because 30,000 is bigger than 11,000. The units are different, right? It would kind of be like saying, well, definitely 5,000 inches is bigger than 4,000 miles. Well, that's not true, right? There's tons of inches and miles. So you can't just look at the number, you have to consider the units. Okay, so when you have different units, what you have to do is get them to be the same units, so then you can compare the numbers. So let's take a look here. What we're going to do, we're going to use the formula that we just got from the previous example. Okay, so I'm going to write our Fahrenheit formula, and that's F equals 9/5 C plus 32. And then what I'm going to do, I'm going to change the lightning from Celsius into Fahrenheit. Okay, so I'm changing this to Fahrenheit, so this way they're both in Fahrenheit, and then I can compare them. So if I want my Fahrenheit when I'm all done, I need to put in my lightning temperature. So the lightning temperature says 30,000 C. So look at the formula. Think about where that's going to go. Where am I going to put the 30,000 in? I'm going to put it where it says C, right? Because that's my Celsius. So I have 9/5 times 30,000 plus 32. Okay, so what I'm doing, I'm taking my lightning, I'm popping it into my formula, and I'm changing it into Fahrenheit. Well, now I just need to do the math, right? So if I go ahead and do that on a calculator, that's going to give me 54,032, which means the sun was 11,000, and now my lightning is 54,032. Now they're both in Fahrenheit, so now I can go ahead and compare them. Clearly the lightning is bigger, lightning is greater, the number is greater than the sun, and so lightning has the higher temperature. Alright, you have one more to do on your own. Number 7, so pause it here, go ahead and try it on your own, and then hit play and check your answer. Okay, so this is actually similar to the previous one, right? So I have room temperature, 7 degrees Fahrenheit, and that just means what's comfortable for most people, okay? And then right now, we'll say current temperature is 23 degrees Celsius. So we don't know if that's greater than or less than 70 because they're in different units. So what I'm going to do, I'm going to take my Celsius once again, and I'm going to change this to Fahrenheit. Okay? Now you'll notice I've given you two formulas now, right? The first formula I gave you was the temperature conversion formula, and that was C equals 5/9 times F minus 32. But then in example 3, we went and solved for F, right? And that was 9/5 C plus 32. So this is really the reason that we rewrite formulas, because sometimes it's helpful to use one, and sometimes it's helpful to use the other one. Now in this case, because I'm changing it to Fahrenheit, I want the same one as the last example. I want this one, okay? That's going to be way easier to work with. So whatever you're changing it to, use that letter on the left. So let's jot that down. Whatever you're changing to, use that variable on the left. Okay, so you may be asking, do I have to memorize both of these formulas? You don't have to. I mean, you definitely need one of them, and then you can move stuff around to get the other one. Could you actually use this first formula here to solve this problem? Yeah, you could, because you could change the room one to Celsius. Either way is fine. So we're going to use the bottom one. So I have Fahrenheit equals 9/5 C plus 32, and the current temperature is 23 degrees Celsius. So what I do, F equals 9/5, put the 23 in here because that's my Celsius, plus 32. Okay? And then I need to go ahead and multiply that out. And on your calculators, by the way you want to do this is, you want to be careful the way you do this. And so the way you want to type it in is 9 divided by 5 in parentheses. That gives you 9/5 times 23. I would hit equals here and then do the plus 32. You have to be careful with the calculator because of PEMDAS, okay? If you were to do this one completely in one step, it would be fine. But it's dangerous sometimes because of PEMDAS, so I like to do it in 2 steps, okay? So if I go ahead and do that, that's going to give me 73.4 Fahrenheit. And remember, the room, so that's the current temperature. The room temperature was 70 degrees Fahrenheit. Okay? And so the question was, is this greater than or less than the room temperature? It's greater, right? So 73.4 is greater than 70. All right, that's it. So be sure to go back and rewatch anything you need. We will be practicing this in class tomorrow. We'll also go back and practice some more absolute value equations in class. And your quiz will encompass everything we've done up to this point, this lesson right here. Okay, have a great night, and I will see you tomorrow.